Okay, so we're going to be talking about compound inequalities. And what happens with a compound inequality, this is where we don't have just a single inequality for a system. And this is going to be something along the lines of, and this is where we're going to introduce kind of formally our words, our mathematical use of the words and or. So if I've got something like x is greater than 1, or x is less than or equal to, say, a -3, when I use the word or, I'm literally saying that x has to satisfy one or the other or both of these criteria. So if I were to look at this, I could say, oh, on a number line, oops, sorry, I made 0, 1, 2, 3, 4. If I take a look at, say, this first thing, x is greater than 1, now there's my 1, anything over here would satisfy this part of the inequality. Well, I've also got this, or x is less than or equal to -3. Well, 1, 2, 3, so there's my -3. And if that's the case, if I'm looking at this, x would have to be, it could equal this -3, or it could be anything smaller than that. So when I'm graphing this, it's literally both. So it's a little bit deceptive. When I see an or is literally going to mean that we could have one or the other, or both of the criteria. Now, if this were an and, I would have nothing on my number line. Nothing would actually satisfy this. So this is where we'll use an or. And like I say, our use of the word and, so let's say I've got something like x is greater than, actually greater than, say, a -5, and x is less than or equal to 0. This is where, when I use the word and, this means that x must satisfy both criteria. So this is a little bit different than how we use and in kind of colloquial English. If we see and, we're going to expect to actually include more. In this case, or is more inclusive than the and is. So here, if I were to put together my number line, I'm going to put my 0 over here. So I've got 1, 2, and I've got -1, -2, -3, -4, -5, -6, so on. Oops, my numbers are getting more scratchier. Here, I'm going to think about this as, oh, x is going to be greater than this -5. And I'm going to, when I'm thinking about this, I'm saying, oh, this means that if I were to do this and do that, this is kind of what I'm thinking of, that this x is greater than that -5. And I'm thinking about this kind of hovering over that for now. x is less than or equal to 0. So I would have, it could equal 0, or it's going to be less than. So in order for this to have both, so this is our x is less than or equal to 0. In order to satisfy both, it's literally going to be just these places where these overlap. So anywhere I've got both of these lines, x could equal 0. X can equal 0 if it's, greater than -5. So yes, that could include that. It won't include our point of -5 because it can't for this first one. And any place where I've got both of the lines, there it is. So this is going to be, this inequality is going to graph like this. It looks, and here I've got this closed interval. So this looks a little bit different than the things that we've done before. Here I've got just one sort of set interval. It kind of starts at this -5 and it goes all the way up to 0. It doesn't include the -5, but it does include the 0. Another way of writing this expression would be like this. If we see an and, we could also do this. I could say -5 is our lower boundary, and it's going to be, x is greater than that -5. So x is greater than -5, or it could be less than or equal to 0. So these two statements mean the same thing. Now, this is the kind of thing that you're going to run into with these compound inequalities. So sometimes you're going to, some questions you're going to run into where you have to just graph this. You might even have to solve for you might have a little inequality equation to solve. With these closed intervals, they can be a little bit trickier. And I'd like to go over another one of these. And here is something that can look really weird unless you've seen it done. So let's say you've got something that looks like this. I'm going to do -7 is less than, and I'll do less than or equal to 2x plus 5 is less than 19. Solving something like this is going to look that would be tough to figure out. But here's what we're going to do. We're going to add or subtract from all segments. So here, if I just had this inequality of -7 is less than or equal to 2x plus 5, I would just subtract 5 from both sides. Yeah, I'd subtract 5 from that and that. And that would be how we would go about solving, or start to solve this one. This would be a -12 is less than or equal to 2x. Well, guess what? The same thing is going to happen if I were to do it here. If I had 2x plus 5 is less than 19, well, I would also subtract 5. So I would end up with, this would be less than 14. So we add or subtract the same thing from all segments. Here I've got 3 segments. I end with 3 segments here. Now I'm going to divide all the segments. So I'm going to divide everything here by 2. That's going to leave me with -6 is less than or equal to x is less than 7. So this would be what this compound inequality would simplify to. Now, the nice thing with, I like this kind of formation. It's a little bit, I think it's a little bit more elegant than using the and, because here you see your variable is literally in between one value and another. It's bigger than the -6, it's smaller than the 7. So literally, if you're graphing this, I could say, here's my 0, 1, 2, 3, 4, 5, 6. There's that -6, and it's smaller than our 7. 1, 2, 3, 4, 5, 6, 7. It's smaller than the 7. It's bigger than the 6. It could equal the 6. It cannot equal the 7, and it encompasses. It could be any value in between these two. So this is what some of these questions are going to look like. And I hope this is a good kind of introduction to this type of question for you.